Okay, really, I could have probably introduced common and natural logs first in video 1, but anyway, here we are. So some logarithms appear so frequently that we come up with shorthand for them. All right, and these are two of them. Okay, so log base 10 is a very common one, and we're just so lazy that we just don't even write the base. If there's no base, it means log base 10. Okay, and that's called the common log. And then we have a similar one for log base e, because Euler's number e, 2.718, etc., is very, very common. It pops up everywhere. We call that the natural log. Or, I don't know, it's kind of weird, right? Like, we call it the natural logs. You might think, oh, why don't we abbreviate it NL? I have no idea. I have no idea. Maybe it's people didn't want it to look like. I have no idea why it's called LN instead of NL. But you can call it the log natural. You want to like tip your hat and adjust your bow tying. Anyway, so that's just shorthand. That's all this is. So we can use this to do a couple things. Example 4, simplify. Part A, log of 100 to the 8th power. Now 100 to the 8th power is a big number. I think it's 1 followed by 16 zeros. Big number, okay? The good news is that your calculator will have the common log and the natural log on it. I would recommend after this video or whatever, looking at your calculator and making sure that you know where they are. If you're taking the quiz on Canvas, HonorLock will also have a pop-up calculator on the right-hand side of the screen. I guess this is right for you. And you can pop that up. That'll have the common log and the natural log as well. So you could just type this into your calculator. Okay. And you should probably do that right now because I'm getting ahead of myself again. Video 1, we talk about video 2. Video 2, we're talking about video 3. Today, we're all out of order because we can also do this a different way. Because let's remember something about inverse functions, right? F of f inverse of x, they cancel each other out. Oh, definitely doesn't equal 0 though. Okay. So in this case, right, the logarithm of an exponential would cancel each other out as well, right? Because these are inverse functions of each other. So if I can write this, what's our base here? The base is 10. We don't write it because it's the common log. But the base is 10 right here. So if I can write this as 10 to the somethingth, then they just cancel out. And we have our simplified answer. And again, you can type this into your calculator. On a quiz, absolutely, go type it into a calculator. On your homework though, if you can do it by hand, it's going to help you so much in future chapter 6 stuff. So please try to do this by hand. So the problem is we have 100, not 10. We want log base 10 because then they just cancel. But 100, remember, that's 10 squared. So we can write it as 10 squared to the 8th power. All right. And let's simplify this a little bit more, right? That's 10 to the squared to the 8th. Multiply those. Exponents multiply like this. You get 16. And now, okay, we have log base 10. We can write it. We usually don't. But just to re-emphasize that these are inverse functions and they cancel each other out. Log base 10 of 10 to the 16ths, inverse, undo each other, boom. All we're left with is that exponent. All we're left with is the input when we take function composition of inverses. 3.4 and 3.7 if you want to review this stuff. And if you type this into your calculator, log of 100 to the 8th power, you should also get 16. All right, we can do another one. Was that part A? Yeah, it was. Let's do part B. Let's do some more of these. Okay, so part B is 2 times log of 0.0001. And again, if this were 10 to a power, they'd cancel each other out and we'd be good to go. It's not though. Sad day. Or is it? It is. All right, conflicting messages in this video. Remember, right? 10 to the negative 1. Negative exponent means reciprocal. That's 1/10 or 0.1. 10 to the negative 2 is 1 over 100, which is 1/100th. Well, we have 3 zeros here. We're going to need 2 more zeros here. That's actually going to be 10 to the 4th is what we have. Okay. This becomes 2 times the logarithm of 10 to the negative 4. Just by continually going on this train of logic. Another way you can do it very quickly is say, okay, 3 zeros, 10 to the negative 4th. 1 0, 2. It's always going to be a 1 bigger number with a negative than how many zeros you have. And then again, we have the 2 before, log of 10 to the negative 4th. These are inverse functions. We're just left with that exponent. So instead of 2 times the logarithm, it's 2 times negative 4 because they undo each other. And they're negative 8. Type that into a calculator, you should get negative 8 as well. Okay. Part C. The natural log, or the log natural if you're refined, the natural log, goodness, of e to the negative 5.03. This is perfect, right? Natural log is the same as log base e. So these are inverse functions already. We don't even have to reformat this, all right? Unlike your hard drive, potentially. They undo each other, and we're just left with that exponent because they're inverse functions. All right, I was going to make an even cleverer reformatting hard drive joke, but I didn't remember the different kinds of formats. I think, I don't remember what they're called. Anyway, here we go. That's example 4. We can do another one too. Example 5. Approximate with a calculator. These ones, obviously, you'll need a calculator. And usually, we'll go to 4 decimal places for logarithms. So all you do is just find the button on your calculator and type it in. If you're having trouble finding it on yours, let me know, and I'll help you out. Okay. All you do is just plug this into your calculator and see what you get. Google, by the way, is what I use for my calculator. So log of 0.04 is negative 1.3979. Hopefully you got that as well. Or hopefully you can reproduce this result. And the natural log of 4/5 will be negative 0.2231. All right. That's all there is to that. And that's video 2, common and natural logs.